Carb heat changes the source of air to the carburetor to an unfiltered intake that is heated by the engine. The warmer, less dense air causes a loss of power when it is tested before takeoff due to an overly rich mixture. In an aircraft equipped with a fixed-pitch propeller, the loss of power shows up as a decrease in RPM. Again, this happens even if there is no ice. Ice can form in the carburetor throat where reduced pressure and fuel vaporization cause a sharp temperature drop. The buildup of ice reduces power because it restricts the flow of the fuel-air mixture. This uncommanded reduction in power is the first indication of carb icing, and it may be followed by engine roughness. Just like with no ice, applying carb heat will cause a decrease in power, in this case on top of the power reduction already caused by the ice. The carb heat will melt the ice, and the liquid water will then be ingested into the engine, which could cause some additional roughness. However, as the ice melts and the flow of fuel and air returns to its pre-icing level, the RPM will gradually increase again. If there wasn't any ice, the RPM would decrease with carb heat and stay decreased, just like it does when carb heat is tested on the ground. If there was ice, it is verified by the gradual increase in RPM as it melts. Answer C. The initial drop in power and roughness can cause a pilot to switch off carb heat prematurely. It is important, however, to give the heat time to work, leaving it fully on until the ice is completely melted, and possibly longer to prevent ice from reforming. Carb heat should not cause an immediate increase in RPM, like in answer A, unless the main air intake was clogged, maybe with ice or snow. In this case, the carb heat would function as an alternate air source for the engine.